arithmetic operations which are related to binary values. Before going into that, I will tell you some of the number ranges which are consequences of binary combinations. So we already know that for a binary combination there are only two digits, 0 and 1, that is two numbers only available. So with a combination of that, if you have 2 to the power of 1, you will get two numbers, obviously 0 or 1. So you will have the values either as 0 or as 1. And if you have 2 to the power of 2, you can have the values as 4 numbers, which can be 0 0, 0 1, 1 0 or 1 1. With the value of 2 to the power of 3, that is combining, this means combining binary digits 2 times. This means combining binary digits 3 times, that is you will have 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1, which obviously you can see here. I think you know how to get the next values. If you add 1 to this, you will get this. If you add 1 to this, you will get this. If you add 1 to this, you will get this. So this will be the consecutive digits when concerned with octal number system. This is called as octal number system. As I already told you, if there is a possibility of 3 combinations, there will be 8 numbers, that is 1 2 3 4 5 6 7 8 numbers will be there, and this will lead to. So moving on with the hexadecimal number system, you will have 2 power 4 values, that is 16 numbers of values, where you will have 0 0 0 0, 0 0 0 1, 0 0 1 0, 0 0 1 1, 0 1 0 0, 0 1 0 1, 0 1 1 0, 0 1 1 1, 1 0 0 0, 1 0 0 1, 1 0 1 0, 1 0 1 1, 1 1 0 0, 1 1 0 1, 1 1 1 0, 1 1 1 1. Here you can see, as you saw here with your octal number system, the same thing goes here. If you add plus 1 to this, you will get the consecutive numbers. Right, here you will have 0 1 2 3 4 5 6 7 8 9. Instead of 10, you will start from A, B, C, D, E and F. So here you can see the same possibility. Till here you will have same as octal system with the added 0 in the 4th place. So when it comes with 2 power 8, you will have 256 bits of combination, which you call as 1 byte, where you will have the values from 0 to 255. As we saw in 2 power 4 hexadecimal, you will have 16 numbers. Here you will have 256 numbers. Here you will have from 0 to 9 and A to F. Here you will have from 0 to 255. Similarly, for 2 power 16, you will have 65,535 bits of values. I think you are clear with what is the number ranges you get from the binary combinations of combining zeros and ones. So you have a possibility to have just 2 numbers, or a possibility to have 4 numbers, or a possibility to have 8 numbers, which is octal number system, and the possibility to have 16 numbers, which is hexadecimal system, or a possibility to have 2 power 8 bits, that is 256 bits, which is going to be 1 byte value, and 2 power 16, which is 65,535 bits, which is the maximum value. And now we will go on with the arithmetic operations or mathematical operations related to binary numbers. Arithmetic operations, or just we call it as binary arithmetic. So in this we will be concentrating on just addition, subtraction, and multiplication. Going into detail, add or sum. To add two binary numbers, as we do with a normal decimal number system, suppose if I am in a position given an example to add 21 and 35, so you will just add it as 5 plus 1 is 6 and 3 plus 2 is 5. So you will get the value of 56. So the thing is, you have to convert this into binary number system, where you will just divide the number by 2. Here you will get 10, remainder is 1. Here again dividing by 2, you will get remainder is 0. Dividing by 2, you will get a remainder 1. Dividing by 2, you will get a remainder 0. So starting from here, you have to write the binary values. So this is the decimal number system, which is converted into 10101. I am starting from here. This is the binary system, equivalent to 21. Similarly for 35, you have to divide it by 2, which comes 17. The remainder will be 1. 2 divided by remainder 1. 8 divided by 2 is 4, remainder is 0. 4 divided by 2 is 2, remainder is 0. 2 divided by 2 is 1, remainder is 0. So 35 will be written as the binary format from here to here as 100011 binary. Okay. So now we need to add 21 and 35, where you will get the binary values as 10101, which is equivalent to 21. And from the value for 35, you will write it like this, where you will get the value as 35, which should be 56. Now before going into this, I will tell you what is regarding the addition table. If you have two values A and B, this is going to be your sum, and you will have another column called carry. If you want to add 0 and 0, this is a normal addition. 0 plus 0 is 0, there will be no carry. 0 plus 1 is 1, there is no carry. 0 plus 1 is 1 plus 0 is 1 is no carry. 1 plus 1, these three comes with a normal addition property, where here with a binary addition of 1 and 1, you will have the value to be 10, where the sum is 0 and carry is 1. So this is the truth table which we are going to apply over here. So 1 plus 1 is 10. We have seen here 1 plus 1 is 10. So 0 we have to write here. Carry is 1. Again 1 plus 0 is 0. 1 plus 0 is 1. Again 1 plus 1 is 10. So again 0, carry over 1. 1 plus 1 is 10. 0, carry 1. 1. 1 plus 0 is 1, again 1 plus 0 is 1, 1 plus 0 is 1, this one. So if we convert this 1 1 1 0 0 0, we will get an equivalent decimal value to be 56. I think you know this conversion: 0 into 2 power 0, 0 into 2 power 1, 0 into 2 power 2, 1 into 2 power 3, 1 into 2 power 4, 1 into 2 power 5. This will be 32, this will be 16, this will be 8, this is 0 0 0. So altogether when you add up, 8 plus 2 is 10, 16, balance 1, 56. So this is the value we need. We have got it in the decimal version. The same value we get it in the binary version. I think now you are clear with what to do with the binary addition. Again recapping, the addition of 0 0 0 1 1 0 is same as normal arithmetic, but when you go with 1 plus 1 you will get the value as 10, where 0 is to be written here and this to be carried over here. This 1 is to be carried over as here. This is what we call as carry, and this we call as augend, and this we call as addend. Finally, this is your answer. We call it as sum. The same principle applies with subtraction also. Subtraction. As we saw with addition, we have seen 0 0 0 1 1 0 1 1. You will get the output to be, when you add this you will get it to be 0 1 1. Here the sum is written as 10, where this is the value and this will be your carry. So now for now you have like this. And if you go with subtraction, you know that subtraction is a reverse process of addition. So when you are adding this and this, you will get this. In reverse, when you subtract this and this, you will get this. So 0 minus 0 is 0, 1 minus 1 is 0, 1 minus 0 is 1, 10 minus 1 is 1. 10 minus 1 is 1. This is the part where we have to concentrate. In normal numbers, we will see the previous number of 2 is 1, the previous number of 5 is 4. But in binary, the previous number of 1 is 0 and the previous number of 10 is 1. This is the hierarchy: 0, 1, 10. 0, if you add 1 to this, you will get 1. If you add 1 to this, you will get 10. As a reverse process, if you subtract 1 from 10, you will get 1. If you subtract 1 from 1, you will get 0. So this 2, if you concentrate and have in mind, you can do the subtraction part easily. And coming to the subtraction, we will take directly the two binary numbers 1 0 0 0 0, which is the equivalent value of 16 in binary decimal system, and another value 0 0 0 1 1, which is equivalent value for 3 in decimal number system. So automatically if we subtract this, we will get 13. We know that in decimal number system. Now we will check it out in binary number system. As I already told you, you have a 0 here, you have a 1 here. To subtract this, we need some number here, not 0. So I am about to borrow from here. This is unfortunately 0. Again I need to get borrowed from here. Again this is also 0. We need to borrow from here. Again this is also 0. This now borrows from here. Now this 1 becomes 0 and this gives this 10 here. Okay, this gives 10 here. in normal subtraction we will take 1 here. Now we will take 10 here, because the previous number, the next number to 1 is 10. We have seen the next number to 1 is 10. Suppose in a normal arithmetic, when we see 4 minus 5, suppose I have a 1 here, we will just mark it out as 0 and get this number to be 14, where 10 is added to this. This is a tens digit for this. So 10 is added here. Same way here, when you give some value, borrow some value from the previous digit, you will get 10. So 10 again here, this is in need of giving one more value to this. So this 10 will go to 1 and this will go as 10. Again this is in need of giving here. So this will go as 1 and this will go as 10. Again this is in need of giving some value here. So this will go as 1 and this will go as 10. Now 10 minus 1 is 1. We have seen here 10 minus 1 is 1. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 0 is 1, which is the value for 13. Okay. I think now we are clear with some concepts of addition and subtraction. When we go on with multiplication, the same logic of normal multiplication what we do. So here we can take some two values as for example 1 1 1 0 and 1 0 1 1. I need to multiply. I am going to multiply this. This is subtraction. I am going to multiply this. As a normal multiplication, 1 into 0 is 0, 1 into 1 is 1, 1 into 1 is 1, 1 into 1 is 1, again 0 1 1 1. When this number is multiplied by 0, everything becomes 0. When this is multiplied, 1 1 1 0. So now on addition, we will get 0 1 here. 1 plus 1 is 10. So 0 carry 1, this is your carry. 1 plus 1 is 10. Then here 10 plus 1 again becomes 11. 1 carry 1. 1 plus 1 is 10. 10 plus 1 is 11. Carry this 1. 1 plus 1 is 10. Carry this 1. 1 plus 1 is 10. So this is how we will do our multiplication part. This is nothing but 14 into 11, which will give you the value of 154. This is the value for 154, this is the value for 11, and this is the value for 14. So if you need further explanations on how to make these conversions from binary to decimal as we do here, I think you are aware of it. If you are not aware of it, you can put it in the comment section to give some more problems related to that, so that we can discuss in detail. Thank you.